What's up, guys? So today we're going to be using Fusion 360 to design some intercooler end tanks, and we're going to design those, save them as a Dxf file, and we'll upload those to a laser cutting facility. I'm going to use SendCutSend.com. I'm really happy with their services, and I've been using them several times weekly for the past couple of months now, so I totally recommend them for high quality and very fast work. So I'm just going to show you, the steps from having just the bare bones of an intercooler core that you bought online to completing it, and there it is, an operational intercooler ready to go. So the core I'm using is 22 inches by 9 1/4 by, I don't know, 3.5. I don't know. It's not perfect. So I took some pre-measurements. So first things first, we want to create a sketch, and we can select any of these planes available here. And what I want to do is create a model of the core, and then I'll build it off of the core. So what I'm going to do right now is make the height and width of it. So I need to do 234.95 by 82.5. Okay, and I'm going to come over here and just rotate it real quick to kind of orient myself a little better and finish the sketch. So now what I need to do is extrude the length of it. So I'm going to select that sketch and either press E on the keyboard or press extrude here, and I'm going to bring that out 22 inches, which is going to come out to 558.8 millimeters, and hit enter. So this is the core, and this is what we're going to start with, and it's a horizontal flow core, meaning the flow is going to come this way and go through it this way. There are vertical flow cores which go down, the opposite, which would be vertical. So what I want to do is move it to this orientation right now, and I want to create a new sketch and start making my end tanks. So what I'm going to do is go ahead and create a line. And I'm not doing anything fancy here with this intercooler. This is kind of like a more generic style intercooler, more universal-ish, that will work for like many people. So I'm just going to bring this out to, let's see, not 80 millimeters. That's pretty far. So I'm going to say, let's go with 60 millimeters at 60 degrees. Let's keep it simple. That's real easy. Then we'll go ahead and bring this up for let's go 86 millimeters. I think that'll work. Because 3 inches, if we put a 3-inch pipe on there, I think that's like 76. So that'll give us like 10 millimeters on each side. 86. Let's go 89. Oh, there we go. 89. Then we'll make another line. Oh, not there. Take it from here to here. Okay, that looks pretty good. So now I'm going to determine the thickness of the plate I'm using, and in my case I'm using 3/16 plate, which is 4.76 millimeters in thickness, and that is pretty thick in comparison to like most intercoolers. I would say they're like probably around the like 1/8 inch range, but I like to overbuild rather than underbuild. So if we could possibly exceed the advertised rating of this core with some type of different fuel or something, or different type of cooling, then this plate will still allow us to exceed that. So that's why I use 3/16. So what we want to do now is select this body and extrude it. Now it wants to extrude it out, and you can see if I do that, then like how it's going to make that look, right? I want it to come in. And it automatically did 10, but it's going to be a negative value. We can already see that. And that's going to be 4.76. And here, if we selected join, it's going to make it all one, which we don't want to do. We want to make it a new body. Press OK. You can start to see the shape of the intercooler. So you can redo that here, but a shortcut would be to come to the bodies, find that body, copy it, doing Control-C on your keyboard, and Control-V. That'll paste another body right there, right on top of it, so we can just move this one over. Until it's flat. So I'm just going to zoom in here and just kind of start playing around with, maybe we'll go 79, 78, so 77.6. Okay, 77.8 is looking good. Okay, so now we have both of those plates placed. So now what we want to do is construct a plane at an angle. And we'll just select this one. And we'll select the orbit so we can move it around. We need to turn it 90 degrees. And press enter. So that's going to give us the ability now to draw a plate across here. So what we want to do now is create another sketch. And we'll select the plane we just drew. Create another line. We'll come to here. You can zoom in to get better accuracy. Then I'll bring that line down all the way to here. Press enter. So now what we want to determine is this line right here. So if you select that edge in the bottom right corner of your screen, it'll say that edge length is 89 millimeters. So I can be pretty well sure that I can just drag it this way, make it 89, and press enter, select L on my keyboard again, and do the same thing. 89. And then now we just have to connect these two. So this will be the inlet of the intercooler, or the outlet. It's going to be the same on both sides. So while we're here, let's go ahead and make a center diameter circle, and let's run it around the edge until it gives us that midpoint constraint. Oh. Then we'll make this 76. It doesn't look like we have much room for weld right here. Like it's going to poke right over. So I'm just going to confirm that my measurements are correct. So yeah, that will need to be 76. So I'm just going to have to play that by ear and just kind of work around that. You can see the other plate's going to be like right on it. So we might have some blending to do, but that's fine. We're fabricators. So finish that sketch. go ahead and select E on your keyboard to extrude it. Let's rotate it to make sure it's going the right direction. 4.76. Now I have our inlet, so it's probably easier to see now what I meant by not much area for welding here. And you can see that right now in the design phase. So that's a good thing about CAD software. So next, let's construct another plane at angle. We'll do it right there. Using that edge, let's go ahead and flip that 90 degrees again. Press enter. We're going to do the same thing. Create a sketch, select that plane. We're going to go ahead and create another line. So again, the shortcut we can use is this edge is 60 millimeters. So when we create the line, it's just, make it 60 millimeters. Oh, it's going at an angle. Okay. Now we can just meet these two. There and there. We're done. We don't need any center diameter, anything in here. We're just going to go ahead and extrude this. It wants to go inwards again, so negative 4.76. Join for a new body. And you can see that it's going to kind of have that shape right there. So we can do one of two things. You could bring this inwards, but that would leave you with a big gap here. So what I like to do personally is just grind this plate flatter here. So once you're, constructing the tanks, I grind it here to make it a little bit flat, and then I go ahead and make the weld. And then here, you can see there's a nice V to push the weld nice and deep and penetrate it really good right there. So for our last plane at angle, we'll just select this one, orbit it around. You can just hit 90 rather than turning it. Create your last sketch. At least for the end tanks. So you can use rectangles here. So why don't we just do that? Might make it a little bit easier. So get as accurate as you want, but that looks fine. So I remember, I think it was going to be, let's see, this width, I remember, should be 82.5. And then that one should be, oh geez, I don't remember. Let's go ahead and redo. All right. Looks pretty good. So now we'll finish that sketch and extrude that. And we're going to have kind of the same thing on the top, where we're going to have to do a little bit of shaving, a little bit of touch work with the grinder. But again, down here we have a really nice V, because this is where the pressure would want to blast that plate off. So what you can do here, I accidentally selected join here, so you can see that it made it all one, versus on the other side is new body, but it's the same plate, so we can just use this file. So let's go ahead, and if you want to see kind of what it will look like when you have like a pipe in there, then a quick way we can do it is create a sketch, and we'll just do it right here. We'll create a line, just find the center. We can just take it outwards right there. Finish the sketch. And what we want to do is create a pipe using this line. And it needs to be 76, because it's going to be a 3-inch. So we'll make that 76. We'll make that a new body. I should have selected hollow. So I went ahead and did Control Z on the keyboard, or you can press back to undo that. I'm just going to move the sketch real quick to the center, so that the pipe will just go right out from the center. So 76, cut, new body, make it hollow with, I don't know, 3mm? How thick are aluminum tubes? I don't know. 3mm-ish. So you can see now that we have an intercooler. I know that looks kind of like, this is a press and pull tool. So we could kind of like adjust this here to make it look a little more realistic. Maybe something like that. So that's pretty much the intercooler that I'm going with. Like I said, really simple design on this one. So what you want to do now for the final steps is create the Dxf file. And what we have to do here is project all of these dimensions to create that. So what we want to do is select our first one. So I'll do this side one right here. And what I do is press P on the keyboard to project it, and I select it and press OK. And then I finish the sketch. And what that does is project a 2D, just a dimensional. It doesn't do the 3D. And that's going to be this sketch right here. So we can go ahead and name this end tank side. And then we can go ahead and do the same here. Press P, select it, finish the sketch, and we'll see it. It's there. So we'll do this one as end tank top. And then do the same here. And then this will be end tank bottom. And then since I copied this one from this one, it doesn't matter, I can just use that single file for those. So the last geometry that I want to project is this one. And then that will be inlet / outlet. So now that we have all of our geometry saved, now what you want to do is come to each one of these and right click it and save as Dxf. So once you save each of these as Dxf type in your folders anywhere on your computer, wherever you want, then we're going to go ahead and upload those to SendCutSend, and they'll cut them for us. Okay, we're finally there. If you guys aren't asleep, if you are asleep, wake up. Now we're going to upload our Dxf files to SendCutSend.com. I've used these guys several times in the past. I use them on a couple times a week basis. They're the quickest, the most affordable, and the most accurate. This stuff comes so fast you have to duck, I swear. I'm not going to show you how to create your own account. You need to create your own account. You should be capable of that. What I'm going to show you is how to upload your Dxf files. So here we are. We're going to browse, and I wish that we could just select them all and input them all, but we can't. We have to do them one by one. So we're going to select it, and it's going to come out and give us a kind of the dimensions of it. So you can see here that it's in inches. So if I select next right now, it's going to come out at 60 by 82 inches. I did that once, and the part that I ordered was supposed to be pretty small. It was huge. So make sure that you change your units to millimeters if that's what you created it to with Fusion 360. So go to your metals. I'm using aluminum for my intercooler. That should be obvious. 5052 is what I prefer for TIG welding. I'll do the 4.7 millimeter thickness. And this is the bottom, so I need 2 of these. So I'll select 2. Next. And add that to my cart. I don't know why that's already there. So I'm just going to remove that. So I want to add more drawings. I'm going to go to my second one. So this is the inlet and the outlet. So I will also be needing 2 of these as well. Okay, it's back in inches. Like I say, this would come massive. I mean, 82 inches would be a giant intercooler. So change that to millimeters. Don't forget. Go back to your metals. And we will need 2 of these as well. Go ahead and add those to the cart. We'll add a couple of more. So the sides, I already know right now, obviously for the side pieces, I'm going to need 2 for each side of the intercooler. So I'm going to need a total of 4. This one's already in millimeters, so that's nice. So metals, aluminum, 5052, back to 4.7. I need 4 of these. So you can go to custom, 2, 3, 4. Add that. And we'll add our last one. 10 millimeters. And this is the top, so I need 2 of those. And next, add to cart. Okay, so what I'm going to do is I'm going to add just another one of these. I'm going to delete it here in a minute, but I just want to show you guys some of the materials that SendCutSend has available. I'm going to leave that one in inches so it sticks out to me that this is the one to delete. later. So for composites, there's ACM, carbon fiber, phenolic. This is really good. This is a good insulator that I used to use on Subaru TGV deletes. I'm sure some of you guys might be familiar with that. And G10, this is something that a lot of people use for like knife handles. Tons of plastics. Delrin's polycarbonate is two total common ones, and HDPE is a common one that it's pretty rigid, but it's not, like it will kind of take a cut. Like if something sharp hits it, it will kind of abide by what cuts it. They only have birch wood and quite a few metals. I have used the titanium, the stainless, aluminum, and steel. I haven't done copper or brass, but I'm sure it's going to be, just as with all their other stuff, which is perfect. So this is the one I need to delete. So you guys seen how easy it is to create something in 2 dimensions and then upload it to SendCutSend. And when it comes, I'm going to show you guys how to weld it. Woo! Here we go. SendCutSend just dropped off the end tank pieces. You guys saw the design process. Here it is in real life. I hope you're awake now. Let's go ahead and open this thing up. Let's get some of these pieces out of here. Okay, so if you've ever Googled or YouTube searched about welding aluminum in the past, you'll know that it has to be extremely clean. And meanwhile, these have been deburred and a surface finish done to them. We still need to wipe off. There is a light dust on it, so we need to get all of that contamination off first before we can even tack it. But our parts look good. Everything looks accurate. So let's wipe them down and get ready to tack it up. Nice and clean, so now we can go ahead and tack these up. So what I do is take one of my pieces, just kind of wipe all the hairs from the paper towel off. And so that's the thickness of the intercooler right there. So this is going to need to go on like this. So I can tack on this piece right now. So looks like it's going to be on there just like that. So what I do is I utilize the 90 that's on this. I just set it on there. And I'll clamp it. And I'll clamp this bottom side as well. And make sure that it's butted up there real nice. So keep in mind that this vice grip, it may leave a mark here, but that'll be on the inside. So, alright, I like the way that looks. Let's go ahead and tack it. So with aluminum, you want to give it a nice strong tack, so that's a little more than a tack, but I remember mentioning in the design that we wouldn't have much room right here, so maybe I can take care of that later, but I'm not going to deal with that right now. But you can see it's exactly as the design showed. So this will be a little challenging to weld, but I think I'm capable. Alright, I'm done building the end tanks, and what I've gone ahead and done is I put a small little divider plate in there, and it's going down at this type of angle. And what that's going to do is, because this end tank is so short and having like such a small volume, is that's going to help direct some of the air up here to this top piece. So if you can see that, that's going to help us utilize as much of this core as possible, since I'm going to try to get all the way up here to this guy. And a lot of intercoolers miss the opportunity of utilizing these upper or the far lower sections. So in hopes that this will help gain efficiency through using all of the intercooler core. So what I'm going to do now is just do a final cleaning on everything before I go ahead and put these end tanks on. And what I'm really paying attention to is right here on the intercooler, because I can verify how clean and good this stuff is here, but I really can't here. So it looks pretty clean to the eye, but I'm just going to take it upon myself to go ahead and wire brush this and this. And I'll even get in here a little bit as well, because the weld will be poking through into this section as I weld it down here. I'm going to go ahead and wipe this stuff off, and also I'll be wiping down my filler rod that I'll be using as well. I'm just about ready to start welding up the outside of the end tanks. Once I complete that, then I'll go ahead and put these pipes on there, and once that's complete, it'll be easier for me to weld this right here, you know, while I can maneuver it like this versus while it's on the core. So once these are complete, then I'll do my finished welding, and I'll go ahead and weld it to the core. I've gone ahead and tacked the end tanks onto the core. I wiped it all down again with acetone, and I also wiped down my filler rod that I'm going to use for it as well. And I'm just going to go ahead, I'll probably start here and here. I'll flip it over and do the bottom ones so that the tanks are kind of held in place. If you start welding here, it might pull it this way and pull it off here. Break your tack weld here and it can pull it out this way. So I want to weld it here and here first to really stick the tank to the core, and then I'll do these last. Alright guys, here's the finished product. I'm pretty happy with it. It came out pretty much like expected. You know, I had the design there, so it was pretty easy to see how it was going to come out. There's the divider plate in the inlet. Yeah, so let me know, what would you guys have done different in the design? What would you have changed? How would you have welded it? Let me know. Give me some feedback about what you would do different. I'd love to know. But first and foremost, get out there and try it yourself. As always, I mean, you're not going to do this good probably on your first one or your second one, but eventually it's going to turn out pretty good and you can build something pretty sweet.